Okay, let's go through this function regarding the piecewise function. So it's given that fx is given to be these two pieces. So sketch the graph of y equal to fx. So for this, we just simply use the GC. So this is the very first piece. Then this is the second piece. Or just remember to label all the endpoints. And of course, our intermediate points here. Okay, then for the part 2, right, we are given the function g to be 1 over x, where x is more than 0. So we are asked to state the range of g, right? So this one quite simple. Also just do a simple sketch, right? So you can see that actually our range of g, right, is from 0 to infinity. So the range of g will be equal to 0 all the way to infinity, non-inclusive. Okay, then of course we are asked to show that the composite function g inverse f exists. Okay, so first thing you will need to do is the 3 circles. So g inverse f, so g inverse f. So of course we start off with f first, and after that I draw a 3 circle first. So this will be your domain of f, then this will give you the range of f, and of course domain of g inverse, right, will give you the range of g inverse. So we just need to ensure that the range of f, right, will be a subset of domain of g inverse. So our g inverse, because we already know what is the range of g, and of course the range of g, so if you remember, is this. So this will be your domain of g, range of g, and then of course this will be your domain of g inverse, and this is your range of g inverse. So means that our domain of g inverse is actually equal to the range of g, which is given to be as such, the 0 to infinity. Okay, so with this, right, I can actually get the thing ready. So this part right here, domain of g inverse, is actually equal to 0 all the way to infinity, non-inclusive. Okay, so what about the range of f? The range of f, we will need to see this graph. So for example, the range, right, is from here, non-inclusive, all the way to here, inclusive. So the range of your f will be equal to 0 all the way to this value of 3. But this one is inclusive, because I shaded this. Then this one is hollow circle. So 0 to 3. So meaning our range of f, right, is 0 to 3 inclusive. Then my domain of g inverse is 0 all the way to infinity. So definitely the range of f will be a subset of domain of g inverse. So that is for this part. Okay, then for, I just want to talk about the last part as well. The last part quite important. So solve the equation g inverse fx, right, to be equal to 1. So this is the so-called intersection point. So definitely, how do I know how to get the rule or the equation of the g inverse f? Okay, so we will need to check. So of course this thing is your y equal to 1. Okay, so I check the first part first. So the first part is the square root 4 minus bracket x minus 2 bracket square, right, where the domain is 0 all the way to 2. Okay, so I will need to check what should be the range of your g inverse f. So for example, so let's write down. So these are the 3 circles. So the very first circle, domain of f, to give you the range of f. And then, okay, domain of f, because they set the first piece is 0 all the way to 2, right? So 0 to 2 inclusive. Then of course the range of f, I simply just need to look at this graph right here. So this graph is 0 all the way to 2 as well. So this is 0 all the way to 2. Okay, then my domain of g inverse, is here. Then of course I equal to the range of g inverse. So for domain of g inverse, I will need to reset to 0 to 2. So domain of g inverse will now become 0 to 2 inclusive. Okay, then of course for the range, right, so for example, because we know that the range of g inverse, so for the g inverse actually just self-inverse, because why? Because y is equal to 1 over x. Then I want to do the inverse, right? I simply just let the x be the subject. Then of course f inverse x, right, will give you 1 over x. So it's like a self-inverse function like that. Okay, then definitely, right, I will draw a rough sketch. So this is your 1 over x graph. So apparently, you can see that the domain of G inverse, right, is 0 to 2. So 0 is right here, 2 is around here. Also meaning this point, right, is about 1 over half. 1 over 2. So this part is 2 half, right? Then of course, at the 0 part, is actually all the way to infinity. Meaning that the range of G inverse, right, will be half to infinity. So why do I need to find this? Because we know now my range of G inverse is half to infinity, meaning I go to here. So domain of G inverse F will now give you the range of G inverse F. So you can see that the range of G inverse F is from half all the way to infinity. So maybe I anyhow do a sketch. So for example, maybe I just do a sketch of here. So this is like my function of G inverse F. So it's something like this. So this part is your half. So this part, right, is your half. And then of course all the way to infinity. So if I want to sketch the so-called y equal to 1, right, y equal to 1 will definitely intersect at a certain point right here. So meaning that our G inverse F, when you want to find the rule of the G inverse F, you must sub in this formula right here, or this equation right here. Okay, what about half x plus 1? Half x plus 1 will not satisfy, because why? Okay, let's do the 3 circles together. So for example, these are the 3 circles. So now my domain of F, right, will give you the range of F. So domain of F is 2 to 4. So this is 2 to 4 inclusive. So 2 to 4 inclusive will then give you the range of F. So range of F is, I go back to the graph. Okay, so this is here. So this is your range. So it's 2 to 3. 2 to 3. So 2 to 3 inclusive. But okay, then after that will be a domain of G inverse to give you the range of G inverse. So now I reset, because I want to find what is my range of G inverse, such that later when I do the substitution, right, I will get the domain of G inverse F to give you the range of G inverse F. So my domain of G inverse will now reset to be equal to 2 all the way to 3 inclusive. Then of course, how do I actually then find what is my range of G inverse? So G inverse is still the 1 over x, right? So this is your G inverse. So this part will be the 2, this part will be the 3. So of course you can see that this part, right, is just half. Then this part will be just equal to your 1 over 3. So now my range is actually from 1/3 to half. So maybe I just roughly put all non-inclusive. So 1/3 to half. Yeah, so meaning when I sub in the second piece into the G inverse, right, my range of G inverse F will only go from 1/3 all the way to half only. So means that that shouldn't be the function. That shouldn't be the composite function. Because if I do a rough sketch of the so-called G inverse F, so if it's something like that, so this will be your 1/3, this will be your half. So my y equal to 1 is actually right here. So there's no intersection, means no solution. So definitely this, if I want to find the rule of the G inverse F, right, I will need to use the first piece. So meaning, okay, for example, G inverse F, right? So F, I simply just sub in square root 4 minus x minus 2 bracket square. So I will get something to be as such, 1 over, because my G inverse x is 1 over x. So I just replace all the x's with this thing. Okay, so that will be the composite function of G inverse F. Then after that, you can simply, because they say solve the equation, right, without any exact value, so I simply just use my GC. So I plot the composite function G inverse F. So I will get something to be as such. Then after that, I simply just sketch another graph y equal to 1, right? So at this point, apparently the intersection will be at 0.268. Yeah, so that is how we actually solve this question.